So hello everyone, hope you're doing really good and welcome back to my channel. Today we have very important question in front of us and this will change the way you see problems, right? This is that level of question, okay? So let me tell you the history of it. From last few days we were having questions on backtracking. Those could also solved using the bit manipulation approach, but they were not mandatorily bit manipulations. We were mostly doing the backtracking approach, right? But today there is a question where we are forced to use bit manipulation, because you will see that this last time mentions that there is a condition which cannot be possible without using the bit manipulation. Okay, that's what the importance of bit manipulation. Basically, I was saving it for this day so that I can tell you the all the gist of it, because the bit manipulations are used you know when there is extreme necessity for maintaining the space complexity, when there is extremely less space. Okay, on those cases only we need bit manipulations. Okay, we'll see that today how it works, because rebate machine is the whole new book itself. Okay, it's not a new chapter in a book, it's a whole new book. Okay, you will have to spend some time to understand it. If you want, you can directly go through my code, which I will give you in the description, sorry, the comments of the video. But if you really want to learn something new, or if you already know and you want to brush up your skills, please pay attention here. Okay, you will definitely learn something out of it and it will be useful for you throughout your life, especially in doing the interviews. Okay, coding interviews. So let's deep dive into the question. It's question number 137, single number 2. Okay, so the question name is not important. Let's come to the question. You can see there is an input. What kind of input they are giving basically? So the input here is, as you can see, just a integer array. Okay, given an integer array nums where every element appears three times except one. Okay, every element will appear three times except one element. Okay, which exactly. Okay, so what happens is, see, for example, if you see twos, they are present the three times. Okay, there will be only one element which is not present for three times. Okay, so where every element appears three times except one, which appears exactly once. What they're trying to say is every element will appear for three times. Okay, except one. Okay, which will appear only once. Okay, find the single element and return it. This is a simple question. Okay, this question looks very simple, just a two-line question. Okay, a question of two lines, right? It looks very simple. You can use hash map and you can get the answer, right? That's very simple. Okay, any kind of hashing you can use, but I will suggest using the hash map and getting the answer. You can also use array for hashing, your choice, your choice. But if you see the like how many values are possible, the values are quite large. Okay, it's not a small number, so you can't use array. Basically, you can use hash map and solve the question if the question is just this much. Okay, but if you include the third line, you cannot use those things. Okay, basically, like, see, if no one is watching, you can use them and your answer may get accepted, but if in incentive review, definitely you can't do that, right? So what's the third line? It says that you must implement a solution with a linear runtime complexity. Okay, it's a linear runtime complexity, still okay, linear is still okay, that's not the hard part, but the other part is very hard. Okay, use only constant extra space. That means the answer should not depend on the length of the array, which is n. Okay, it should not depend on n, it should be a constant one. Okay, that's what they are trying to convey. So I've already told you, if you want to use the array for hashing, let me tell you that this is going to be really big if you are going to use array for this much length. Okay, if you have to cover this much length, okay, minus 2 raised to power 31 till positive 2 raised to power 31 minus 1. Okay, the length should be this much. Okay, it should include both the ends, and then you can use the hashing basically to store the frequency. That also you can do, but obviously that is not going to be acceptable. So I've already explained you this part of the question looks very simple. I am not going to give you the code for this. Okay, we will just try to understand why this works. Okay, how to get code for this. Okay, I hope the question is clear to you. Okay, so always there will be, see, for example, if you consider two, it is present three times. Okay, always there will be one element which is not present three times and it is present only once. Okay, we have to return that element, so we are returning three here. Okay, that's the idea. Coming to the second example, you can clearly see zero is present three times. Okay, one is also present three times. Okay, you can just see where yourself, so these are the ones present, but 99 is present only once. Okay, so we have to return 99. Okay, you can see the time complexity is here. And see, when you see here this thing, something should come to your mind. Okay, I will give you a hint here. See, the idea here is, please try to understand what is the maximum and minimum value that can be stored in an integer in C++. When I say integer in C++, it basically means in a variable which has a size of 4 bytes. Okay, size of 4 bytes. Okay, that's what integer is in let us say C++. Okay, please try to understand what is the maximum and the minimum value that can be stored. Okay, I'm not talking about unsigned int. I'm talking about signed int. Okay, which is the basic default int. Okay, so please once Google and see. Okay, definitely will get some answers, and by those answers, you should be able to understand what I'm trying to convey. Okay, this is the hint for that. Okay, The idea here is all these values whichever they are trying to give here can be stored in a single integer. Okay, why? So I will explain you that, but yeah, I will just want to make you feel what it is actually. Okay, why these questions are important. Okay, if you see this part of the question, if you see a medium tag, you will understand that okay, it's a lucky day for me. But once you come to this part of the question, you will realize that it's not going to be easy, right? So let's deep dive into the solution. I will again say, see, if you already know these things, please don't waste your time. You can just go and learn something new. But if you're new and you would really want to want to learn something, and you have really see, if you want to learn kind of things like bit manipulation, you need to have some time, right? Please have that time arranged, and then please see the video after this. Okay, if you don't have the time, please stop the video now itself. No need to go further. That's what I wanted to convey. Okay, let's now deep dig deeper into this. Okay, so as I've already mentioned, okay, a integer in C++, I'm talking about a signed integer. Okay, so it will be a 4 bytes. So, see what is the difference between signed and unsigned? Please, you can search it yourself. Okay. The bit idea here is if you are talking about uh, a normal integer, which is signed integer, what will happen is a single bit is reserved. Okay, a single bit is reserved to determine if it's a positive integer or a negative integer. If you talk about unsigned, we don't reserve a bit. Okay, we already know it's going to be only for the positive numbers or only for the negative numbers. So in that way, we don't reserve a number. Okay, don't reserve a bit. Okay. So what happens is, see, it's 4 bytes. Okay, so 4 into 8 bits. Okay, which is 32 bits. So basically, the biggest number that can be stored here is 32 bits. But as I mentioned, one bit will be stored for getting the to know if the number is positive or negative. Okay, that number will stored. If you remove that, it becomes 31 bit. So the maximum answer that can be stored here is of this length. Okay, 2 ratio of 31 till it's negative on the negative side, and on the positive side 2 ratio of 31 minus 1. Why we are doing this minus 1? Because we are going to accumulate 0 also. Okay, we are going to accumulate 0 also, so we have to do minus 1 on the right side. Okay, that's the basic idea here, friends. So I hope these things are clear to you now. Okay, now please pay attention. Everything will connect. Okay, everything will connect once you look back, but please pay attention to the things now. Okay, look forward and just follow what I'm saying. Okay, now let's talk about what is negative number. Okay, negative numbers are represented using two's complement. I will come to this part when I talk about one part of the code, but for now just try to understand. Please pause the video and take a screenshot of it and just try to spend some time here. Okay, for example, if I talk of 24, this is the binary representation of it. Okay, how it works. See, I think in previous video I have mentioned that, but now you should be knowing these things. Okay, it's called 8421. Okay, see, for example, every place has a value here. Okay, the first place has a value 1, the second place has a value 2, the third place has a value 4, the fifth place has a value 8, and the sixth place has a value 16. Okay, so 16 plus 8 plus all zeros. Okay, so 16 plus 8 it becomes 24. Okay, if you talk about the 8-bit format, what happens is I make it as 8-bit. Okay, that is I add zeros to its left, and this is how it looks. Okay, what is one's complement? Okay, one's complement is just reverse it. Okay, wherever there is 0, add a 1. Wherever there is 1, add sorry, wherever there is 0, add a 1. Wherever there is 1, make it 0. Okay, so exact reverse of it, you will get the one's complement. Why we need this, will come to that later, but just now understand what is one's complement. Add a 1 to it, do a simple calculation, you will get 2's complement. Okay, so basically what happens is that a computer will store a negative number in its 2's complement. So why we learned all these things? Just to understand the fact is that for a positive number it will stored like this. Okay, please see my mouse pointer here, it will be stored like this. Okay, it will, the left part of it will be 0. Okay, the last, that is the leftmost bit, that is called the most significant bit, because it has a lot of value on its side, right? So that will be the 0. Okay, that will be 0. But if you talk about a negative number, it's MSB. Okay, most significant bit will be 1. Okay, and it will be stored in the 2's complement format. Okay, so because my code is going to be in Python, and in Python all negative numbers are stored in 2's complement. That's why I want you to teach this. Okay, so what will happen is that, see, so there are tricks here how to see. For example, how to convert it from this format which you're seeing here to this format. Okay, very simple. Keep following. See, this 0 remains the same. This 0 remains the same. This 0 remains the same. This one remains the same. After that, we will start the reversing. This one will become 0 here. This 0 will become 1 here. This, what happens is that means keep, same thing will follow. Okay, in both, till we receive, we see a 1. After that one, things will start reversing. Okay, that as simple as, see, I'm comparing this and this. Okay, that is the 8-bit format and the 2's complement. Okay, so how to convert these things are important. Okay, if, see, the answer, if it comes negative, we'll have to convert it, and then only you have to give the answer, right? That's why we need this. Okay, if you don't understand, please let it be, but just try to understand. Whenever the answer is negative, we will need this. Okay, okay, I will come to this later, but yeah, just understand that. Okay, see, I am assuming that you will have the opportunity to pause the videos and forward and backward, all those things you can do, and get some ideas of it. And obviously you have Google, right? So now let's understand what is left shift. Okay, see, these things are very simple, but I'm trying to cover so that even everyone, even the beginners, learn this. Okay, and obviously you need some refresh, right? Even if you know these things. So what happens is that we are talking about left shift. What happens is that, see, left shift basically means that one is shifted left to two times. Okay, means left shift one by two places. Okay, what I will do, I will left shift one by two places. Okay, so basically one is one. What will happen is I will left shift one by two places. So two zeros will come in its front. Okay, so its value will now be four. Okay, so one left shift by two becomes four. Okay, this is the binary representation. I will just write a b here. Okay, I will just write some space and b so that you will understand that this is the binary representation and not a number. Okay, so 100b means it's a binary representation of the answer. Okay, so if you convert it by decimal, okay, what happens is, as I mentioned, 8421 the place values. Okay, so you can see the one is in the fourth place, so the answer is 4. Okay, similarly the right shift. Now, so remember, always the shifting operators come to the right. Okay, see, the number and how many places it should be shifted. Okay, similarly the number 5 and how many places it should be shifted. Okay, in this case we are talking about a right shift. Okay, means right shift. Okay, right shift 5 by 1 place. Okay, right shift 5 by 1 place. Okay, what happens is, see, 5 right shifted by 1. Okay, what is 5 basically? 5 is basically 101. Okay, 101. If I shift to the right, you will see the last one will go off. Okay, so it will remain as 1 and then 0. Okay, 1 and 0 in binary. If you convert it to decimal, you will get the answer 2. Okay, so I assume you know these things. Okay, 5 is basically 101. If you remove the last one, it becomes 1 and 0. If you now convert it to decimal, it becomes 2. Okay, so I hope you understand these things. Now we'll dive into the solution. Okay. So basically, my solution is only this much. Okay, this is the only solution. But for converting a negative number to a positive number, this much code I need. Okay, this much code I need. That is just why I'm giving you the idea. So my code is only this much. Okay, my code is only this much. But let's see now. Okay, this is going to be the answer which I'm going to return. Okay, initially it is 0. Okay, what I will do is I will revolve around 0 to 31. Why? Because, see, I am going to go through each bit. Okay, for each bit, for example, if I is 0 now, okay, what will happen is, for the 0th bit I will go for each of the numbers. Okay, I will try to go through the 0th bit of each of the numbers. Okay, I will try to go through the 0 bits of each of the numbers. What I will see, I will just count which, see, I will go through 0th bit of each of the numbers, then I will go to the first bit of each of the numbers, then I will go to second bit of each of the numbers. What I will do is, in each case, is that I will count how many ones are there. Okay, for example, if I talk of 0th bit, I will go through 0 bits of each number and I will count how many ones are there. Okay, that will be stored in count of 1. Okay, see, these things I will explain in detail, but just try to understand the logic first. What will happen is, after each loop, that is, after finishing the 0th bit of all the numbers, I will count how many ones are there in each of them. Okay, then I will check if the number of ones percentage is 3. That is, if the number of ones are a multiple of 3. Okay, that means the answer 0th bit is not a 1. Okay, please note this points down somewhere. This is how you are going to do it. See, I will go through the 0th bit of each of the numbers. Okay, then I will calculate how many of them are ones. Okay, because, see, uh, once I know how many of them are ones, I will also know how many of them are zeros, right? That's the idea. So once you know how many of them are ones, okay, then I will just try that count. I'll just try to see if it is a multiple of 3 or not. If it is a multiple of 3, that means my answer's 0th bit is going to be 0. Okay, if it's not a multiple of 3, that means my 0th bit of my answer is going to be 1. Okay, as simple as that. Please pause the video, please go back 5-10 seconds, and please try to understand what I'm saying. Okay, I'm trying to say that for the 0th, I will go through the 0th bit of each of the numbers. Okay, if then I will count how many of them are ones. Okay, if that count is a multiple of 3, okay, that's it's a multiple of 3, that means my answer 0th bit is not going to be a 1. Okay, if it is not a multiple of 3, that means the 0th bit of my answer is going to be a 1. Okay, that's what we are going to do. Okay, so I am going through each of the numbers. Okay, J represents each of the numbers, I represents the bit for which we are going to do. Okay, so this count of 1 will tell me number of ones in this bit. Okay, for each of the numbers. Okay, so how I am getting that, it is very simple. I will just zoom in and show you. What I am doing is, I am shifting the number by I times. I am right shifting the number. Okay. What happen? For example, see, suppose I have 5 here. Okay, and this is the first bit. Okay, I am going to I want the first bit. Okay, 0th bit, then the first bit. Okay, so I will right shift for 5 by 1. Okay, so what happens is that that bit I want will come to the LSB. That will come to the LSB leftmost bit. Sorry, the rightmost bit. Okay, what will happen? See, this operation ensures that the bit I want will come to the LSB. Okay, will come to the LSB. LSB means rightmost bit. Okay, then I will do a AND with one. Okay, then I will do a AND with one. What it ensures that only that bit remains. All the other bits are removed. Okay, okay. What happens? For example, see 101 is there, right? I will just show you. See, 101 is there, right? I want this bit. Okay, that is the first bit. Okay, this is a zeroth bit. Then the first bit. Okay, I will achieve it by one. Okay, if I achieve it by one, what will happen is that it will become one and zero. Okay, then I will do a AND with one. Okay, when I do AND with one, what will happen is that only the zeroth bit will come. Okay, only the zeroth bit will come. Okay, only this bit will come out. Okay, so whenever you do AND with one, if it is one, it will remain one. If it is zero, it will remain zero. Okay, that's the basic idea. So all the things are done to get the ith bit of the number. Okay, the ith bit of the number. Okay, I'll just comment it out so that it helps you. Okay, ith bit of the number. Okay, so yeah, I got the ith bit. Then I will check if it is one or not. See if the ith bit is one, that means I will just add it to my count. If it is a zero, no need to add to the count. Okay. Then I will check if it is a multiple of three or not. If it's a multiple three, my answer's ith bit is going to be zero. If it is not a multiple three, my answer's ith bit is going to be one. Okay. It's a one. I will add it to my answer. How I will add it? See, I will take this one. Remember, if it is a zero, I will not do anything. Because see, answers anyway, all bits are zero only as of now, right? If it is zero, I will not do anything. Only if it is a one, I will add it to my answer currently, okay? Because zeros are already present, right? What I will do is see, I know that ith bit of my answer is going to be one. What I will do, I will shift I to the ith bit. Okay, I will shift I to the ith bit. Then I will do OR with my original answer. Okay, I will do OR with my original answer. Then, sorry, what I am saying is, one will shift it to the ith bit. That number will be done OR with my original answer, bitwise OR with my original answer. Okay, so my the now for this answer will have a side bit as one. Okay, that's what I'm trying to say. This is my whole answer. Okay, if you return the answer now, you will get definitely correct answers, but only problem will come is when you have negative numbers. If the answer is negative, for example, in this case, as you can see, the answer is going to be -4 in this case. If I remove the other part of the code, this case will not be cleared. Why this happens? This happens because, see, try to understand, the negative numbers are stored in the 2's complement. But if you take this as a normal number and if you try to calculate 8421, all those things, if you try to do, okay, then it will give you a very, very big answer and it is a wrong answer. So what we have to do, see, whenever the answer is going to be negative, see how to know first of all when if the answer is negative or not. Please comment in the video. If you have listened carefully, you will definitely know this. The answer is that, see, when the MSB, okay, if the MSB is 1, that means the answer is negative. If the MSB is 0, the answer is positive. Okay. What I will check is, I will check the MSB of my answer. See, this part of the code is going to give me answer, no doubt in that. But if the answer is a positive one or negative one, I still don't know. So what I will do is I will check the MSB of my answer. If it comes 0, that means written as it is. Okay, written as it is. If it comes 1, then we will need to process it. Okay, we cannot convert it to my answer just like that. We will need to do some processing. What is that processing? I already mentioned that. Okay, see, please make it very clear what I'm trying to do. See, once you know, see, I have the answer in this format, the two's complement format. I want to convert to the 8-bit format. Okay, what I should do? See, as simple as that. This 0 is there, take it there. This 0 is there, take it there. This 0 is there, take it there. This 1 is there, take it there. Once you witness 1, after that, everything should be reversed. After the first one, everything should be reversed. Okay, this 0 is there, reverse it to 1. This 1 is there, reverse it to 0. This 1 is there, reverse it to 0. This one is there, reverse it to 0. What the answer is? So, idea is start from the this, okay, start from the right, whatever comes, take as it is till you receive the first one. Once the first one comes, after that everything should be reversed. Okay, that's what I'm going to do here basically. Okay, I am checking now the MSB here. Okay, if the MSB, okay, I will just write it here so that it, you know, helps you. Okay, checking the MSB, to understand if it is a negative number. Okay, I'm just checking the MSB. Okay, I'll just increase the font size. Yeah. So the same thing what I did here. Okay, that same thing I'm doing here. Okay, answer I'm shifting by 31 places so that I get the MSB to the first place. Then I'm doing a AND with one. If it is a one, that means the answer is going to be negative. Okay. This part of the code ensures that I deal with a negative number. Okay. If the answer is not negative, return the answer as it is. This part of code deals with that answer The case when the answer is positive, return the answer as it is. Okay, this part of code deals with when the answer is negative. Okay, what I should do, I will write invert. Okay, invert equal to false initially. I will go through each of the bits of the answer. Okay, bit, I'm just getting that bit. Okay, I'm getting the ith bit from the answer. This is as it is. Okay, what I did here now, same thing is being done here. Okay, same thing is happening here. Okay, I am shifting I answer by that in places and add doing add with one. Okay, this is the ith bit basically. This bit is the ith bit. Okay, I'll just write it here for your convenience. This is the ith bit of answer. Okay, so what will happen, as I mentioned, till I receive the first one, take answer as it is. Okay, so invert initially is false, so this code will not be executed. Okay, what will happen is this code will be executed. Okay, so what is this code? This code tells that whatever you get, see whatever is the bit is the ith bit, right? So this bit is the ith bit. Okay, so left shift it by I mean I times and or it with one. Okay, this is what we did here, right? This is what we did. Exactly same thing. Okay, exactly same thing. Okay, but till you after you receive the first one, things will change. Okay, so after you will do this. Okay, now see this part, this code lies here. Okay, once you receive that one, see after one things will change. Okay, see first one, take it as it is, but after you receive the first one, things will change. Okay, when you move from right to left, when you receive the first one, it take it as it is. After first one, okay, whatever you are seeing here, things will change now. Okay, things will change now. Okay, so that's what we are doing here. After you receive the first one, invert will be made to true. Okay, next time if invert is 2, we will now reverse everything. Okay, if it is 0, make it 1. If it is 1, make it 0. Okay, if it is inverse, if it is invert, this part of the code now will be executed. Okay, previously what we did, we took everything as it is. Okay, everything as it is. Now the invert part of the code will execute it. Okay, what it means, if it is 1, make it 0. If it is 0, make it 1. Okay, that's what we are doing it. If it is invert, this part of the code will execute. What we are doing, we are checking if it is 0. Okay, if it is 0, now I have to make it 1. Okay, I have to make it 1. So instead of 0, I will have 1 here. Remember previously whatever came, I did exactly that. But this time when we have 0, I am going to take 1. Okay, that is the only change. Now when 1 comes, we have to do 0. Okay, the 0 we don't need to do because already 0 is there everywhere, right? You can avoid that step, or you can do it also, no problem. But you can avoid that step. Okay, so when a 0 comes, I have to revert it to 1. That's what we are doing here. 0 came, I reverted it to 1. Okay, that will give me the origin this answer. Okay, for example, from the 2's complement, I am getting the answer now. Okay, just like this. Okay, I got the answer now. Okay, so my answer 2 is my real answer. But for example, see here, if you have -4, after doing this procedure you will get 4. So you have to finally do a multiply with -1 and you have to return. I will just quickly run and show you the cases how it works. See, I've explained every part. Okay, it may be a faster one, but I am expecting, because see, you are watching this in YouTube, right? YouTube has so many features. You can, forward the video, reverse the video, stop the video. So use those features. See, use the technology for your benefit, right? That's what it is. So here, as you can see, all the test cases are getting cleared. Okay, even the negative ones. Okay, so yeah, often that was the answer. This is the original answer. Okay, but for dealing with negative cases, this is the answer. Okay, this part of the code will be added. Okay, why? Because negative numbers are stored in 2's complement. We'll have to convert it to the 8-bit format. Then we have to return it with a minus sign. Okay, see, this question basically expect us to return them with a minus sign. Okay, rather than the simply the direct answer with the inverted 2's complement format, right? That's what it is. So yeah, fun, that was all. And yeah, if you talk about the time complexity, what we're doing is, see, the time complexity will be very basically 32 into n. Okay, 32 into n. Okay, because for each see, n loops are there, n numbers are there for each of the 32. So 30 into n. But if you convert it in a logical way, it will become more fun. Okay, and similarly, coming to space complexity, as you can see, we are not using anything basically, only some constant answers. Okay, answer and answer to, only two things. Okay, so it will be basically constant time complexity. So one thing is very sure, when I answer this question, see, when I started this question, I told you for this thing only we are going to use bit manipulation, because otherwise there are so many ways to do it. Okay, and when I'm closing this video, I'm again saying this is why we did bit manipulation, because bit manipulation allows us to use the bits of the, see, there are so many bits basically. Okay, if you talk about integer, there are 32 bits in it, and we used all of them this time. Okay, so whenever you see something like this, okay, whenever you see this kind of conditions, always have in some corner of your mind, always get this idea that it should be related to bit manipulation. Bit manipulation can be very, very easily done here, because we can have an integer of 32 bits and we can manipulate it. Okay, that's what it is. Remember, if it is even if it is suppose 33 or 34, we cannot do it. Okay, why? Because see, this answer will exceed. Okay, in C++ language you cannot do it. Okay, and obviously they will not give such a question for other languages also. As simple as that. Okay. So yeah, friends, that was all for today. uh, I think this will be the longest video I had, but I am definitely hoping that after seeing this video you will be having a lot of ideas about paper impression, and you will have a lot of hints coming to that. Okay, whenever you see such a thing you should be able to identify it now. Okay, so yeah, friends, that was all. See you tomorrow. Thanks a lot.